Right, question 1. There are 50 counters in a bag. The counters are blue, yellow, black, or white. The counter is taken at random from the bag. The table shows each of the probabilities that the counter will be blue, black, or white. Work out the number of yellow counters in the bag. So we need to know that probability is out of 1. Okay, and we've been given these 3 decimal numbers here. So what we need to do is add them all up. So we've got 0.4 plus 0.3 plus 0.16, and that gives us a total of 0.86. So if probability is out of 1, to work out what's left over, we do 1 take away 0.86, which gives us 0.14. So this probability is the value for the probability of yellow. To find the probability of yellow, we've got the actual probability itself, so 0.14 times the amount of counters. So we've got 50 counters, so it will be 0.14 times 50. And if we do that calculation, we can make that 50 and 14. Just remember that we've made this number, so when we get our final answer we can move it back. 0 times 4 is 0, 5 times 4 is 20, a box here. 0 times 1 is 0, 5 times 1 is 5, add these up, 0, 0, 7, we need to move this back, 1, 2, so our final answer is 7.00 or 7 counters, and that's yellow. Question 2, here is a trapezium. All the measurements are in centimeters. The area of the trapezium is 18 centimeters squared. Calculate the numerical value of the perimeter of the trapezium. So we've got the area of the trapezium and the perimeter of the trapezium. So when I say the area of the trapezium, I need to remember the formula for that, and that is area equals half the sum of the parallel times the height between them. So you might have, or you will have area equals half. Now the parallel sides is this side here and this here. So then we're going to have 2x minus 3 plus, because it's the sum, 2x plus 3 times the height, which is this value here, the 4, not the 5. Then we have area equals, so let's deal with the brackets first, let's collect some like terms. 2x and 2x is 4x, minus 3 plus 3 will give us 0, so we're left with just 4x times 4. Now we can do area equals half of 4x is 2x times 4, so area equals 8x. Okay, now you can do what I did here, so you do half times the bracket, which gives us the 2x that you saw here, or you could do 4x times 4, which is 16, and then half that to give you this 8, just the same thing. Now, they told us at the beginning that the area of the trapezium is 18, so then we've got a equals 8x, so instead of a, we've got 18 equals 8x. Now I'll rearrange for x, we're going to have 18 over 8, so how many 8's go into 18? So we can do some division here. 8 into 1 is 0, carry the 1. 8 into 18, well, that will go twice, gives us 16. 2 decimal points and a 0. We've got 2 left over. How many 8's go into 20? That would be 2 to give us 16. So we've got 16 to 20 is 4. So we've got a 4 here. And then how many 8's go into 40? That's 5. So x is 2.25. Now we need to calculate the numerical value of the perimeter. So the perimeter, don't forget, is the outside of the shape. So if I'm going to put a circle here and start here, I'm going to start with 5 plus 2x minus 3. I encourage you to circle these pluses to separate each side. So 5 plus 2x minus 3 plus 5 plus 2x plus 3. So if we looked at collecting the algebra now, we've got P equals, we've got 5 and 5, so 10. We've then got plus 2x plus 2x is 4x. And then we've got minus 3 and a plus 3, which will cancel out. So therefore we have P equals 10 plus 4 open bracket, where x is 2.25. And therefore we have P equals 10 plus 4 times 2.25. That will give us 9. So therefore the perimeter is 19 centimeters. That's our final answer. Okay, question 3. Work out an estimate for the value of 6.8 times 191, all divided by 0.051. So we're going to make this 6.87 times 200, all divided by 0.05. So if you're looking at that, the trickiest bit probably is working out what value this to go to. Some of you may have been inclined to say 0. Some of you may have been inclined to say 1 to really kind of round it up, but that would be too much. So you need to think of, when you're asked to estimate, to try and make it easy for you without the use of a calculator. Now obviously this is not a calculator paper anyway, but if you kind of go with that mentality of thinking, if you look at this, in which way can you make it easy for yourself, that should kind of steer you in the right direction. So then we've got 7 times 200, well we can just do 7 times 2, which is 14, and don't forget the zeros. So that's 1400 divided by 0.05. Now what we can do is we can manipulate this to make it slightly easier. So when I say that, I mean we can times this to make it 5. We'd need to times it by 100. And whatever we do to the bottom, we do to the top. That way if we do the same thing, we're not changing anything, or the value itself. So then this will become 14,000, so 140,000 divided by 5. So then we can do 5 into 140,000. 5 into 1 would be 0, carry the 1. 5 into 14 is 2, which is 10, and then there's 4 remainder, so we put the 4 there. 5 into 40 would be 8, and then there'd be no remainders, so we would end up having 28,000 for the answer there. And that would be our 3 marks. Right, question 4. The diagram shows a straight line L1 drawn on the grid. A straight line L2 is parallel to the straight line L1 and passes through the point 0, minus 5. Find an equation of the straight line L2. So we've got some keywords here in this question. The first keyword is this one here, parallel. Now if we remember, parallel means it has the same gradient. Okay, so we should start thinking, if it's got the same gradient as this L1 graph, we need to be thinking, how can we work out the gradient on this graph? Okay, and there are a few ways of doing it, but that's kind of what we should be thinking as we read this question. Next, it says that it passes through the point 0,5, so we're given a set of coordinates, and these coordinates are going to come into play when we're using the equation of a line. So equation of a line is y equals mx plus c, where m is the gradient and c is the y-intercept. So gradient being the slope, so whether it's a positive gradient or a negative one, and the y-intercept being where the line crosses through the y-axis. So let's start off with the gradient. So it says it has the same gradient. So what we can do is we can pick 2 points that are on the grid. So here, for example, and here. And we can find the gradient. So we can do that by remembering the formula, where m is y over x. And all that means is we can draw this triangle here, like so, and work out the distance. So always check your axes here, and you'll note that this is going 1, 2, 3, 4, 5, 6. So they're going up in intervals of 1. And here as well, 1, 2, 3, 4, 5, 6, 7. Okay, so they're going up in ones. Now the reason I say that is sometimes the scale here can be different to the y-axis. So just double check that. So if we're asked now to look at how high or how tall this triangle is, we've got 1, 2, so there's 2 boxes here, so that would mean we'd put number 2 here. If we look at the base of the triangle, we've got 1, 2, 3, 4, so we'd put 4 here. Now using this formula here, m equals, well, we just fill this in. So our value for y is 2, and our value for x is 4. Now we can simplify that. 2 over 4 simplifies down to 1/2. So we know for this equation or line L2 that the gradient is 1/2. So if I write y equals half x plus c, this is our line L2, or the equation of the line L2. Now we need to find this plus c part, and this is where the coordinates that were given up here will come into play. So all we need to do is substitute these values in. So I know this is my x value and this is my y. So my y value being -5 equals 1/2 x, where x is 0, plus c. Then I've got -5 equals, what's half times 0? Well, that's 0, so we're just left with plus c. Therefore c is -5. So if we write what we know from the gradient and what we know from the intercept, we end up having y equals half x minus 5. And this is the equation of the line for L2. Question 5. Describe fully the single transformation that maps triangle P onto triangle Q. So you should be able to look at that fairly quickly and see, okay, it's a reflection. Now, this is out of 2 marks. So one of your marks will be from saying it's a reflection. Okay, and then we need to say where the reflection is. The reflection in the line, and it would be this line here, wouldn't it? And at this line, this is the line x equals 5. And the reason it's not y equals 5 to what you're normally used to seeing is because y equals 5 would be this value here. Okay, so let me just quickly explain. The line x equals 5 is taken into account that anywhere on this line the value of x is 5. Okay, if we said y equals 5, we're talking about, like I said, this one up here, and any value here is 5. Obviously that's not where the triangle has been reflected, so the equation or the line where it's been reflected in is x equals 5. And there's your 2 marks for that. Part B, enlarge rectangle R with a scale factor 3 and center 4, 0. So common mistake is to think the center is always here and then start drawing your lines from that. So our center point is actually 4, 0, meaning here is our center point. Now what you can do is get a ruler, connect these lines up. So this is from this 4, 0 point to this vertice is obviously one diagonal across. I'm just going to do that with the remaining vertices. So obviously you'd use a ruler to make sure that these lines are perfectly straight. Next, what I'm going to do is I'm going to write the value of each one. So here I've got 1, here I've got 2, here I've got 2, and here I've got 1. Now next is where I apply the scale factor. So I'm going to start with this bottom right one down here first. Well, 1 times 3 will give me 3. So instead of 1 across, I'm going to go 1, 2, 3. And that's my new point. So now if I do that with the second point, 2 times 3 is 6. So I should end up with something like this. And there's my point. And I'll do the same for the bottom left. So 1 times 3 is 3. Therefore 1, 2, 3 is my point there. And for the last one, 2 times 3 is 6. So we get this point up here. Join it all together. You can just do a quick check. It's 1 in height, the original. 1 times 3 is 3, so we've got a 3 in height. And then we've got a width of 2, and 2 times 3 is 6. We've got 1, 2, 3, 4, 5, 6. So we know we've got our 2 marks. Right, okay, next question. Shape S can be transformed to shape T by the translation 0 minus 3 followed by rotation. C, describe the rotation. So let's do this transformation. So we need to remember this is in vector format. So x and y, so we do not move this left or right, we move this 3 down. So each of these 3 points, I'm going to move down 3. So 1, 2, 3. It's going to end up there. 1, 2, 3. It's going to end up here. And 1, 2, 3. That's going to end up here. So let me just do that in a different color. Okay. And now the question is asking us, how do we get from this shape, which is S dash, to T? Well, we can see this in 90 degrees clockwise rotation. Okay. And now we need to find out where the point of rotation is. So is it, for example, here? So if we spin that shape around here, would that get us to this T? Well, if we span it around there, it would probably end up something like this. So that wouldn't be the case. So in an exam, you'd have tracing paper. So what you do is you trace shape S dash, so our new one, and then you just put your center of rotation point, say for example at 0, 0, and then you try and rotate until you get to the point. Now the point does happen to be 0, 0, so it would be 90 degrees clockwise rotation about 0, 0. Okay, but you may instantly get that in an exam, or you may try here, 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 etc. Just continue to do so until you actually get onto this T shape here. Okay, the lines y equals x minus 2 and x plus y equals 10 are drawn on the grid. On the grid, mark with a cross x each of the points with integer coordinates that are in the region defined by the following. So we've got these 3 regions. So looking at x greater than 3, I'm going to mark that now on the graph. So it would be this line here. Okay, and greater than 3 would be this entire region. Now I want greater than 3, so what I'm going to do is I'm going to rub or scribble out the opposite side. So instead of scribbling out this side, I'm going to do these lines here. Okay, and then that's the x greater than 3 done. Next we move on to the y greater than x minus 2. So here is the line y equals x minus 2. We want greater than, so that's going to be above. So greater than, so again we want the greater than, so we want the above. So I'm going to shade this region everywhere underneath that line here. Okay. And now if I look at my last question, or last statement, I've got x plus y is less than 10. So that's this line here. Okay. And I want less than 10. So less than 10 is obviously all here, but I want that. So instead of shading that region, I'm going to shade this region here. And now it reveals what I'm left with, which is this region here. So usually you're asked to call it R, but in this case we're asked to write the integer coordinates. So the integer coordinates being this point here, this point here, this point here, and this point here. So if we write that, we've got 4, 3, we've got 4, 4, 4, 5, and 5, 4. So we've got these 4 coordinates as our final answer. Right, question 7 is a circle theorem question, so let's have a look. A, B, C, and D are points on the circumference of a circle with centre O. Angle ABC equals 116. Find the size of angle marked X and give reasons for your answer. So with circle theorems you should be able to spot 2 patterns fairly quickly. Let me just highlight what those 2 patterns are. So your first one you should be able to spot is this arrowhead, which is the angle at centre is double that at the edge. And the second one will be the cyclic quadrilateral, which is where opposite angles add up to 180. So this cyclic is the one that's going to help us get started. So if I just write here, write cyclic quadrilateral, then I've got this angle here equals 116. I would like to find this angle here. So I'm going to call this angle Y, and let's say Y. So to find angle Y, it's going to be 180, take away 116, and that equals 64 degrees. So if angle Y is, let's just rub this out, is 64, we know from the arrow, or the circle theorem, that the angle at the center is double that at the edge. So for 2, let's put angle at center double that at edge. So if that angle there, ADC, is 64, then AOC, so angle AOC, that is 2 times ADC, so therefore it's 2 times 64, therefore it is 128 degrees. Okay, and you could expand a bit on the statements and reasonings, so you could do a bit more of writing like angle ADC rather than just 116. So what you could do is you could write 180 minus angle ABC. Okay, and then you could go from there and then substitute in 116 and so on. Okay, so you do need to kind of put a bit more statement and reason, but that's quite enough in order to get you going. You can kind of finish that off towards the end. Okay, question A. M is directly proportional to L to the power 3. When L equals 2, M equals 160. Find the value of M when L equals 3. So M is directly proportional to L cubed. So M directly proportional to L cubed. And then we need to, of course, change this to M equals K L to the 3. So this is our starting point. We're given L equals 2 and M equals 160, so we can substitute that in to find our value for K. So M being 160, K is what we're trying to find out, and L is 2. So then we can do 160 equals K times, and then 2 to the power 3 would give you 8. This is K times 8, so to get K by itself we would divide by 8. So 160 divided by 8, then 8 into 16 is 2, add the 0. Therefore K is 20. So now using this original equation here, we can now fill that in. So this happens to be M equals 20 L cubed. So now it says find the value of M when L equals 3. Well, this equation here is set out for M, so we can just substitute in the value for L. So that's M equals 20, 3 to the power 3. So M equals 20 times 27. So therefore M equals 27 times 2 is 54. Add this 0, and we get an M value of 540. Right, question 9. Prove algebraically that the sum of the squares of 2 consecutive integers is always an odd number. So what I'm going to do is I'm going to call first integer x and the second integer x plus 1. Now if I just stop and think about this, I'm just going to say let's go for the number 1. The next consecutive integer will be the next number. So the next number would be 2. And if we just have a look at this algebra, if x is 1, then of course x plus 1 will give us 2. So remember, it's not x and then 2x, because that would be twice the value of the next number, not necessarily the next number. Right, so rubbing that out, we can then stick to the algebra that we need to do for the proof. So wording is important to have a look at here, to make sure you don't make any mistakes. So it says here, prove algebraically the sum of the squares. Okay, so sum important, so that would be x plus 1. So that's the sum because it would be them added up. And it says sum of the squares, so then all of this would be squared. Okay, so prove that they some of them always add to an odd number. So let's see, this would make this x squared, and this would be x plus 1 squared. So then we'd have x squared here, then plus x plus 1, x plus 1. Now we could use FOIL, so we can have x squared plus x squared plus x plus x plus 1. Collecting the like terms, we have x squared plus x squared plus 2x plus 1. And finally, 2x squared plus 2x plus 1. So we've got this, and what we can do is extract the 2. So we end up with 2x squared plus x plus 1. And we need to remember that the 2, how it plays its part, where any number that has a factor of 2 would be an even number. Therefore, this section right here would be even, and 1 would be odd. And if you have an even plus an odd, that would leave you with an odd number. Okay, and you can try this. So say, for example, you pick any odd number. Let's go with 4 as the even plus an odd of 1. That gives you 5. Let's go with 8 as an even plus an odd of 3. That would be 11. Okay, and so on and so on. So an even plus an odd will give you an odd. So you need to understand the role of what the 2 has, and how it determines what makes it an even number. Right, okay, number 10. Given that 8 minus root 18 all divided by root 2 equals a plus b root 2, where a and b are integers, find the value of a and the value of b. So if we write this down, we've got 8 minus the root of 18 all over root 2. So looking at this, what we should be thinking immediately is we need to rationalise the denominator. So we do that by times it by root 2, top and bottom. So by doing so, we end up with root 2 times 8 minus root 18 all over root of 4. Now that will go to, let's just write again, root 2, 8 minus root 18, and simplify the denominator, so that would be 2. Then we'd have 8 root 2 minus root 36 over 2. Then we can write 8 root 2 minus, well, that would be 6 over 2. And then if we just write this down here, because we're running out of space, 8 root 2 minus 3 over 2. So what I've done is I've simplified the minus 6 over 2 as 3. Okay, and then I've not just got rid of the divide by 2 for the 8 root 2. So then we can simplify this part. So 8 divided by 2 would be 4. So 4 root 2 minus 3. And this will be our final answer. Now, it does say that we want it as a plus b root 2. So all we need to do is change this around. So this would be minus 3 plus 4 root 2 is our final answer. Therefore, linking them up, a would be minus 3 and b